Hello everyone, welcome back to another Kinetic Tutoring Calculus video. Today we're going to be taking a look at the power series and some power series problems, so let's get straight into it. Alright, so the power series is a way that we can find out whether a summation is, or an integral is divergent or convergent. So basically, if an integral is divergent, that means that the value is going to go to infinity, not a finite number. But if it is convergent, then it goes to a finite number and doesn't go to infinity. So then we have our two examples. We have our Okay, so here's what we're looking at. This is going to be a constant p. It's a sum, or we can have the integral constant, and p is our value from any number, another constant to infinity, another constant to infinity. So we're taking a look at this value p, and this value p will determine whether it is the summation is going to be convergent or divergent. So we just go based off this rule here. If p is greater than 1, then the series converges. But if p is less than or equal to 1, then the series is going to diverge. So let's take a look at our practice problem here. We have, oh, sorry, this isn't a constant. This is going to be, rather, the p is a constant. This is going to be our sum that is going to infinity, right? Or our variable that is starting at a finite value and going to infinity. So here we have k, as k goes from 1 to infinity. Let's say this is also from 1 to infinity, 1 to infinity. K is going from 1 to infinity, and p is remaining a constant value. P is not changing. If p is greater than 1, then the series converges. If p is less than or equal to 1, then the series is going to diverge. So as we can see here, we have a p value of 5. P is equal to 5. And then we can put this in here. 5 is greater than 1. Therefore, the problem is going to, the series is going to converge. Let's move on to another practice problem. Here we have this practice problem here. 1 over the 5th root of k squared. So let's take a look at the bottom part. We have the 5th root of k squared. This is simply equal to k squared to the 1/5, which is also k to 2/5. So then we get this, k to the p. P is equal to 2/5. 2/5 is going to be less than or equal to 1, and therefore this series is going to diverge. For this last problem, we have to find out whether the series converges or diverges, and if it does diverge, or rather if it does converge, we have to find what value it converges to. Basically meaning, okay, so we have all of these sums added up from 1 to infinity, and either they go to an infinite number that cannot be counted, or they go to a finite number that can be counted. The area under the curve can be measured, and if it can be measured, we have to find what the area is going to be. So, in addition, when we're taking a look at a power series problem, we're going to be taking a look with the power with the highest, the exponent, the variable with the highest exponent. In this case, it would be x squared, so we could ignore the 1. And this 7 can be brought out to the side, so we get 1 over x squared. We can ignore the 1. 7 can be outside the integral. Just for the sake of seeing if it is convergent or divergent, p is 2. 2 is greater than 1, so therefore it is going to converge, meaning that it's going to reach a finite value. And therefore, our next step is to find out what this finite value is. And the way we can do this is through using our answer is through solving the improper integral. You get 7 integral from 1 through to infinity, 7 1 plus x squared dx. Oh, there's no 7 here. This is a 1. From here, we're going to make a limit as t approaches infinity and call this up here t, 1 to t, 1 plus x squared dx. This equation here, it may be familiar to you. If not, it is the arctangent equation, meaning that when this integral is evaluated, you're going to get arctangent of x is what comes out of the integral. So we get 7 times arctan x evaluated from 1 to t. So we get 7 arctan t minus 7 arctan 1. There you go. 7 arctan t is going to be 7 arctan infinity. We can bring the infinity back in. Minus 7 arctan 1. Let's draw out our arctan equation to figure out what arctan of infinity is going to be. Here's the equation of arctangent, and here we have two asymptotes. One is going to be at pi over 2. One is going to be at negative pi over 2. So as arctan approaches infinity, the y value approaches pi over 2, so arctan of infinity is going to be pi over 2. That times 7 gives you 7 pi over 2. And then you subtract 7 arctangent of 1. So 7 arctangent of 1, you can use a calculator to find out what that is. I'm going to go on my calculator really quick to see what that's going to be. That's just going to be 45 degrees. So 7, and if we want to convert it to radians, 45 degrees to radians is going to be pi over 4. So we get minus 7 pi over 4. So 7 pi over 2 minus 7 pi over 4 gives us the final answer of 7 pi over 4, meaning that the value of this summation, the area under the curve as the graph approaches infinity, is going to be 7 pi over 4. Let's get a visual really quick. That's going to be the last part of this video. 7 over 1 plus x squared. So when x is 0, it's going to be 7. And then as x gets greater, the value is going to get smaller like this, approaching 0. So this area under this curve is going to be equal to 7 pi over 4, and it's going to be approaching 7 pi over 4 as this x value gets closer and closer to infinity. That's all I have for you guys today. Hopefully you learned something from this video. If there's any questions, comments, concerns, make sure to leave them down below, and I will see you guys next time.